So, all of you guys that own AMD have probably been privy to the fiasco that's been going on the last few days. I think it was yesterday morning, around the same time. In fact, this recording is taking place around maybe like 24 hours after the video was posted. So I've done quite a lot of testing now, and the reason why I've delayed this video has been because I wanted to get it like absolutely perfect, to get everything in order, and by this point I've done quite a lot of testing. So as you can see on the left, the Zen timing screenshot, pretty much what you're seeing there is, you could say, like pretty much perfect. Now, I know I've said it before, like in previous videos, that I thought that everything was correct, but it turns out that, I think I'm not sure if no, I didn't. I removed the one video. I haven't informed you guys yet. So basically, someone in my comments made me aware of the fact that I might have misinterpreted the math that was on OCN. It turns out Vase, the way he kind of wrote out the equation, I was a bit confused, but basically, this is how it is officially meant to be done. So pretty much take this value, so well, I'm gonna do it simply for you guys, because to be honest, the virtual timing doesn't really matter, does it? Because you can't see it, so most of you guys won't even know what I'm talking about. So let me just do it like this so it makes more sense, obviously. So basically, this is the equation. It's this value will be this value minus this value plus 1. So it's just these. Now, the equation doesn't actually use these values, but more so CCD values. So CCDL and then CCDS. That's not to say like the Ryzen CCD, like the actual, like, the part of the die. No, it's a timing. It's a timing that Intel has as well. It's like a base timing that other timings are calculated from. And that timing itself is related to the burst, the T burst timing. So basically, that doesn't really matter. What you have to know is this. This is what you're gonna find valuable for your own tuning, and this value over here on Ryzen, which you can see on my config, is going to be 24, which I like as a value for it, to be honest, is Phi RDL, which is 12, and that times 2. So pretty much that, and then this timing, which you see over there, is 17. You can probably see where this is going. So this is why it's important to note this is not the RRDS. You're actually using CCDS, but I think maybe I'll do this rather. We're gonna assume that so I'll go ahead and replace these for you guys, just so we can be more technically accurate. Now, does this actually matter? It can matter. That's the thing. It depends, right? It depends. Now, I know these timings are real, because if you try and set these other timings to like whatever you want, it doesn't matter. When you set the SCL timings, that's what matters. I think WRWR SCL is a weird one, but RDRD SCL, if you tighten it too far, you will not train, you will not post. That timing, it does set, and the other timings will autocorrect around it and kind of mold to become, or adhere to that value rather. I'm not exactly sure how the board does it, but it does it somehow, and you can see some like performance loss depending on how it trains. Now, there's something else that's very important that I haven't mentioned. So, what actually determines how good you can run like TestMem5 or any application, I've actually found now, this is actually what determines it, and that is Phi RDL. When Phi RDL trains in equally on both DIMMs, everything is good. When Phi RDL is broken, that's when you start seeing performance degradation. And Phi RDL being broken also indicates, like, you know, you might have training issues down the line, like, you know, from cold boots, which is something I dealt with when I try to mess with these timings, and I'll get to these just now. This is objectively correct. So basically, so this is something that should kind of be followed, because apparently it is good for making sure that you have, like, you know, good transitions and, like, you know, commands, and just not have like training issues and dropouts. So this is actually something you should follow. I found now, again, it doesn't seem like it's making much of a difference to TM5, but it can make a difference in stuff like gaming, you know, like when you run workloads for long periods of time. Like, it's more so that when you run a workload for long enough, you start seeing dropouts and inconsistencies when you have timing mismatches. And again, when you have the mismatches, Phi RDL will train badly. A lot of guys' configs online, if you actually look, a lot of them are dealing with that issue, and myself as well. In fact, the only way I fixed Phi RDL was actually when I started messing with these timings. And again, you're going to be like, well, you were using ones before, right? Well, I was. Funny enough, ones autocorrected. I was being told they might be autocorrecting. I wasn't sure, because I was like, it doesn't make sense, because Intel has different rank, different DIMM timing, so why on Ryzen? So a few guys trying to explain to me that actually DDR5 is, even though you have a single rank on your, you know, your DIMMs, like one side, like a single side in the DIMM, that like on most of our kits, right? Because most of us are on 32 gigabytes, right? So most of our kits are single-sided, but somehow DDR5 has this weird thing where it's like it envisions like a virtual rank, which is kind of strange. Now, you would think that's complete nonsense, right? Well, actually, no. Yeah, I had a lot of problems, because I tried setting these two timings to 4 to match my 4 that I had on this value. I had 4 here. Now 4 is actually the minimum of these. That's why this one should actually be 4 as well, minimum, not 3. I tried 4 and I could not train from cold. Could not. It was way too difficult. And I tried 6 on all of them, and 6 was like better but still failing. And yeah, 6 was working on the DD but not on SD. Eventually I had to go straight to 8. So 8 on all 3 of them. That trains cleanly and I can run without errors. In fact, I haven't actually had an error, but like, that trained. Nothing else trained. I could not train 6s. I couldn't train 4s. The only way to get all 3 of these matched was by using 8. And then I used 8 for here, because this was fine. This surprisingly did work with this one. Just as is. And so basically, when you don't run them, like, you don't actually set them properly, those timings get like either like not used or autocorrected, and that's where it comes in, which is like, so where would it matter? I guess you could say hey, I don't know. I mean, look at SCL, for example, like WR SCL 17, like, to use one of these would be quicker, right? So these would be, you know, quite a bit faster. These would be kind of comparable to just, you know, any of the short timings, but like, yeah, so, like, yeah, these would still be like, you know, on par with the short, which is still, I mean, better than this or whatever. I mean, like, look, they do help. I mean, they help over time, but yeah, you should want to use them. They do set, which is kind of strange, but they do set. So I would recommend actually using them. It's actually the strategy now to use them. Some guys set the SD to 1. I'm not sure, but like for me, when I tried SD at like too low a value, it actually needed me to set it higher, like to actually get it to post and stuff. So when I use SD, like when the timing becomes activated, when you leave the 1 state, which is non-existent. So 1 means not used, but when you leave the 1 state and you go to activated, when there's actually activation, yeah, then yeah, it's hard to run. It needs all the way to 8 for me on SD. So I'm using them. I'm not sure what I'll see, but it's correct, and it does help my training. So it helps my Phi RDL training. Without setting them, it's like this can just break between boots. Setting them just changes the training protocol. It just makes everything way better. I mean, yeah, right now the config is pretty much cleaned up, like completely cleaned up. Now, this is probably not what you guys wanted to hear about, because this is kind of mundane. It's not really like super interesting stuff, but what you would want to know about is the SoC. So yeah, I've decided to go all the way down to 1.25 SoC because 1.3 SoC in my testing runs at 1.35 on the external readout. Now, I'm not sure how accurate this readout is, if we should be using this one or this one, because in my mind, this is the internal voltage. This is like die sense, right? This is like socket sense, almost, in a way. It's external sense. It's a sensor outside the CPU. This is the board sensor. This is not the CPU sensor. This is not even the VRM sensor. I mean, the VRM sensor would be a VR VOut. Well, if they had it. This controller isn't the RAA, so, or the ISL, whatever. But yeah, this is external. So I would imagine that this would make more sense to look at and be like, that's the reading. But I would say, guys, I'm almost at the point where I'm thinking 1.25 is the way to go, because you can run like 2100 megahertz on FCLK, even on like a sample like mine, which is not like crazy good. I've run 2167, but honestly, guys, even at 1.275, okay, 2167 didn't feel so good in Windows and stuff, and 2167 at 1.275 SoC actually lost the TM5 data load. Like, it literally caused the you know, that bug where like you lose, like, where all the memory allocated test just like gets dumped back into the, like, where the test literally relieves the memory and like it's like it stops testing. That's a loss in communication there. That's SoC. Someone was saying it could be a CUP optimizer. I agree, it could be, but I thought, nah, it's SoC, because SoC essentially just dictates the entire like stream of data. I mean, SoC powers what, like Fabric, IMC. It's like the SoC is probably the most important voltage on the chip, because it powers the Fabric and the IMC and parts of the CCD. So it's like, it's such an important voltage, the SoC. So yeah, I thought SoC, and I was right 100% right. When I dropped it down, when I went back to 1.3, the PC immediately felt better than 1.275, and the testing looked good. But I was looking at this readout, and it was saying 1.35, and it was bothering me, and I was like, you know what, screw it. I cut the test off at 10 minutes in, and I was like, you know what, back to 1.25. I set 2100, and it ran straight through. And this feels stable and good. You can tell if you have SoC issues just by moving the mouse around, looking at tabs, flicking them around. Like, it might sound silly, but literally, like, you know, SoC is off when like the memory test is testing kind of slow. If you, again, like when you lose the data in TM5, when the test stops testing, you can do a few runs of like, you know, Y crunch or whatever. But yeah, SoC at 1.25, I think most guys will end up running around this kind of, you know, value. It's hard to say for sure, but around there. I would say for now, stick to 1.25 SoC. For me personally, on my board, I cannot run gear down disabled without running this value on APU V3IO. This value was absolutely required. At 1.3, it was a no boot. It's at cold boot. At cold boot, there was no boot with GDM off. So from cold, just complete like black screen. Also, I get a weird beep. So when my board wants to tell me that it failed training miserably, it like beeps immediately. Like as the PC starts, I get this loud beep, and that tells me it failed CPU initialization. So it's like it failed, almost like when Intel CPU fails initialization because of SA, because of like low SA. Same idea. So basically, when certain timings or certain things are off, it doesn't even try and train. It just fails, and that's that's what happens when I run this too low with GDM off. And and also V3P 1.15. I was like, you know what, saving 50 millivolts wouldn't really matter. And you know, with these timings I'm running, like it was so difficult to get them to train in the first place. I was like, you know what, I'm gonna run the highest, viable V3P voltage, and I'm just running these two now. So this is, I mean, borderline, but I would say quite safe. I mean, this is not internal, so this should be fine. I still think SoC is a bit troublesome now. I'm not too sure about it. I like running 1 volt on my CLDO, like V3G values, because honestly, 1 volt feels way better to me than 950 in OS. Like in OS, like flicking around and stuff, like 1 volt feels so much more stable. 950 millivolts feels like, I don't know, it feels a bit clanky, like a bit clanky. So I don't know. It sounds funny, but yeah, literally with Ryzen, you don't often see errors. Like you can see that the fabric is kind of, like not so stable when it just like begins to regress performance. You don't really get like errors like that, like Intel, where it's like just red errors everywhere. It's not really the case with Ryzen. You get more like degradation on performance before you see errors, to be honest. So yeah, interesting. But I think that's pretty much all I wanted to say, guys. Like the timing rules are pretty much here for you guys. This timing is, as low as you want, but I'm telling you right now, these two are very hard to drop down. Obviously it's depending on your own setup, but like this is quite hard to tighten. So I'm running 8, but I'm sure someone else could run 4 if they wanted to. And otherwise, 8 on, so So basically, if you drop below that value and you drop down to like BL16 mode, apparently like you just lose a lot of performance. I think you might gain latency like benefits, but I think you can't really. It's hard to make it up for without like I don't even know. I think. By that logic, you could use lower values at like higher data rates, and then maybe it makes sense because now you have the extra like throughput, but yeah, I don't know. I think 8 makes sense. And then the SCL math works out nicely because when you do like 4, for example, you end up with like a theoretical min value of like 1, and 1 is pretty much impossible to train. So I don't know. I would say stick to 8 now. Yeah, that's pretty much it, guys. This is, I mean, for a lot of you guys, about as good as it might get. So, okay, this is something you guys could try now. I think I'm confident to say, like, if you guys have, ADI, so obviously don't ignore these values, but it's 1.45. So right now I'm doing 1.45 volts on both, VDD and VDDQ, 1.8 volt VPP, 1 volt on my V3G values, and then 1.25 SoC, 1.15 V3P, 1.35 AP V3IO, and then these timings on ADI. ODTs here, I need them. They definitely help me. In fact, without these ODTs and proc ODT, I can't even train power down disabled like at the same voltages. And also I need VDDQ up there as well. I couldn't train like, you know, gear down without this up here, and like power down. Like, so actually, like, everything you see right now has actually been tested. I tried lower values, but no. Maybe something might be able to go down by like 25 millivolts, maybe 50 at max, but most of what you see here is pretty much minimized, like, for what I need for my setup, for these timings and stuff and everything to work out nicely. Like, this is what I needed. This should be safe. You know, SoC is perfectly fine at 1.25, and this is fine. 1.45 in your ADI is good if you have cooling. If you have like a fan in your RAM, it's fine. Yeah, so honestly, this is like a pretty usable set. I'd say this is pretty much like, I mean, yeah, I think some users would find this to be a pretty like stable setup and work pretty well. Obviously it depends on your sticks, like, and what they do, voltage wise and stuff, and your own IMC. But I'd say this is pretty much like, this fabric speed at this kind of SoC is pretty realistic, I think. Yeah, I would stay away from 1.3, guys. I would stay away, because look, a lot of motherboards seem to have like SoC readings in BIOS that are way below what ends up, you know, being the actual value. So I would say, you know, be more conservative and rather, you know, be safe. It's not really worth 67 megahertz, right, to potentially degrade your CPU. Thank goodness, like, you know, I haven't had any weirdness. So I think for all I've done testing wise, I'm gonna say, like, you know, like, knock on wood, but I think I'm pretty much, I think I'm fine for now. I think my CPU is somewhat safe. A lot of guys online too, like, have said they've been using like 1.4 and stuff, and they said they've been fine. I mean, they're not actually having issues. So I'm surprised, but yeah, I'd say don't freak out yet, guys. I don't think it's so. The one thing is, right, the one individual who had their chip die immediately, the guy on the Eurus board, right, the guy who had a what did he have now, man? He had a B650M something. Yeah, he had the B650M Eurus Elite. Now that individual, his chip died without any expo, and he also died like immediately. Like, the chip died immediately, like when it I think on first boot. I'm not wrong. I'm not sure, but like it died at stock or something. Now I think Steve might have said that like one of the BIOSes causes like a 1.45 volt spike, but I don't know. Like, I'm not so sure, guys, if it's necessarily just the SoC value, or if it's also like a factor of just having a bad CPU sample, because it might really just be the case that like some CPU samples are really bad, and that's why you know, the AMD have sold millions of chips, guys, and the weird thing is, like, you don't see thousands of dead CPUs. So like, AMD have sold millions of CPUs, and you don't see thousands of dead ones. So I don't think that it's that widespread. I think it might just be the case that like some really bad samples can't even handle, like, you know, relatively reasonable values, because Bulldoid and a lot of other members of the forum have said, like, you know, they've had contacts in these companies that have said, like, hey, no, no, I'm not saying, but like after the drama, I mean, like, you know, earlier on, like, you know, months ago, they would say, oh, what's the SoC maximum? They would say, like, oh, it's like a 1.45, or oh, it's 1.4. And on the forums, even, people were running 1.44 volts on SoC for like 6600 megabit transfers per second, and like, you know, 6400, for example, and running like 2200 megahertz FCLK, and for the longest time, a lot of them had no problems at 1.4 volts. So I don't know, I'm very confused, because it just doesn't make a lot of sense. It's a whole weird situation, but those chips look ugly, man. Like, the damage when you took the heat spread off, like, it's a lot of damage on some of these CPUs. It's quite alarming. I know it is. Very confusing situation. I don't know. It's a very, very weird spot for AMD to be in. I'm not sure what they're gonna do. Yeah, just guys, just keep an eye out on your own stuff and make sure you're running reasonable values. And yeah, I would say just stick to, you know, safe values over performance, I would say. But yeah, guys, hope this video helped or provided you guys with information. And you know, these timings again, like they're pretty much solid. I think this is where I would say no more violations. Just this should be, you know, these should be safe. TWR48 is no longer obeying the TWR math. I wasn't so sure about that. I don't know, but apparently a lot of guys are doing it. Even they. So I don't know. I think 48 is doable. It doesn't make a lot of sense, but I guess, you know, it's whatever. I guess it's fine. But yeah, I mean, that's it. I think I'm gonna stick to this now for the next, you know, few days till maybe like if the new BIOS comes out, I'll see what that can do. Maybe it somehow allows better training or whatever. I don't know. But yeah, so yeah, keep your guys' chips safe and avoid those RMAs, guys. But cheers.